All right, so today we're reviewing some of the concepts from these past couple days here, the 6.1 through 6.2, basically all the exponential stuff we've been learning. So it says for a yearly rate of change of minus 22%. In other words, losing 22%. The first part says write the growth or decay factor. First off, it's definitely a decay factor. And when they're talking about that, they're talking about when you're writing your base exponential equation, what would this b value need to be? So it's going to be 1 minus the 0.22 because you're losing 22%, which would make that value 0.78. So that's the decay factor. You're keeping 78% of the population each time. So now it says write the equation. So this would be one where since there's no a value, it's basically saying the a value is 1. And the equation would just look like that. And is it growth or decay? We already kind of said that. Definitely decay. Obviously, if you're losing percentage, it's going to be decay. If you're gaining a percentage, it's going to be growth. So pretty straightforward. If the problem had some sort of starting value, like if it said there's a population of 10,000 people or whatever, you would simply have a 10,000 in front here. Okay. The next one, talking about transformations, says for this big exponential function, how is it different than its parent function? So the base function is just 2 to the x, the doubling function. What do we have going on here? Well, we have kind of a lot of things. We have this 1/2, which means it's going to be compressed by a half, like we've seen all year. That's basically just going to mean it's going to be squished down. No negatives anywhere, so this +3 will make it be shifted left 3, and the -5 will make it be shifted down 5. Beauty of stuff like this is, I think I've said this a whole bunch of times, but you can always graph them and double check things. So if you put in that parent function, you take a look at what it looked like. You're like, yep, solid doubling exponential growth function. Now if I do all this stuff, what's going to happen? So I've got the 1/2 times 2 to the x plus 3. And then at the end of that, -5. So let's see if it does the shifts that we expect. So we definitely say down 5. I see the down 5 looks pretty clear. The asymptote's down 5. Shifting it left 3 does look like that's happening as well. You can see the curve of this has definitely been shifted from where it would be. And as far as the compression, that's a little bit harder to see visually, but you can see this is a little more squished than that one is. That one's a little got more steeper type of thing going on there. So yeah, definitely makes sense, fits all the stuff that we're saying. So yeah, there you go.